In the name of God. In this film, we want to teach how to record LFP signals, local field potentials, by the devices eLab, ePulse, and the software eProbe. Installation of the software has been taught completely in the other film. Now, we want to teach how to work with the LFP protocol. As you see, there are several menus at the top of the screen. In the center, there's the scope sheet, which shows signals. And at the bottom, there's the section related to timing settings, the device for the stimulation. In the top menu, if you click on the device, a window is opened, the first item of which is eDevice. If you have connected the device eLab to the computer by the USB port, you can see USB eLab herein on the right. Now I disconnect eLab, and you won't see the same option anymore. I will connect eLab, and you will see it as USB at eLab, which is the code related to your own device. The second option is device 2. If you want to also have electrical stimulation at the same time of recording using scienceBeam company's device ePulse, you should set the second option to ePulse B. And if you use other stimulators, you should click on Other, so that you will be able to run the system for synchronization of eLab with the stimulation isolation devices. Well, for now, I'll choose ePulse B here. For connecting ePulse and eLab, as you know, there's a connecting cable with HDMI at the two heads, which connects to the top of eLab and ePulse. Well, at the top screen, you will observe the signal. If I have a right click on it, the scope settings will come up. Data stream defines whether the data being acquired is from channel 1 or 2. eLab is usually with 2 or 4 channels. This third channel is related to the digital output. It's not considered among recording channels. Now, this is a 2-channel device. If it were the 4-channel one, there would be up to channel 5 here. VD, that is voltage division, and TD, that is time division, are related to display parameters of the scope screen. VD is 100 microvolts now, and TD 5 milliseconds. To understand this concept, I start by clicking on the scope button, as I want to have some bass noise. I have placed the electrode into normal saline as a liquid. It's not inside a being's brain. Now, you're watching the noise of the city power. I make a right click again and make the time division closer 50 milliseconds. The signal is then shown with more intensity. Likewise, I turn the voltage division from 100 to 500 microvolt. Here's the baseline, which is 0 microvolt, then 500, 1000, 1500, so on. Each square has an amplitude of 500 microvolts, which is the vertical line, and 50 milliseconds, the horizontal line. The other options are HPF and LPF, high-pass filter and low-pass filter. For different recording, we set the filters with different numbers. If we want to have ECOG, standing for electrocorticography, HPF is set to 1 Hz and LPF to 100 or 200 Hz. If we want to record LTP for learning and memory, we set HPF to 1 Hz and LPF to 3 kHz. For recording single unit, HPF becomes 300 Hz and LPF 3 to 5 kHz. Now, we want to record an LTP as sample. I set HPF to 1 Hz and LPF to 3 kHz. The other settings are not defining for this task, but only for human recordings. The only remaining factor is signal. There are 2 options, which are related to eLab: spike and field. If you're supposed to record single unit, you choose spike. By this, the sample rate of the device sets to 50 kilosamples per second. And if we choose field, the sample rate of the device will be set to 10 kilosamples per second. There's another button at the end named Trigger. If I make it on, the scope stays fixed, and if make it off, it will continue its moving. You will know this more when teaching the Stimulator. For now, we make it off. I'll close this window and we'll go to the window below. I click on Stop. there are some settings for the stimulators. Stimulator mode to be either off, normal, or inverted. If it is off, no stimulation will be applied via the stimulator cable. Otherwise, stimulation will be on. On the inverted mode, polarity of the stimulator will change. As per stimulator current, the accuracy of the stimulating current is adjustable by 1 microamp. It ranges from 1 to 4000. Now I choose 100. Well, as I said, you can set the current of the stimulator at 1 microamp accuracy. In this section, you define the location where you will save the data of your recording. By clicking this button, you can choose any place you want. For example, I want to save this in drive D, the folder signal, and name the file test2. Then you should click on Save. The window below is experimental protocol file name, the protocol for recording and stimulation, by which you can carry out recording timing and the method of stimulation. Design protocol is related to making a new protocol. Through the File menu, you can choose your protocols. If you click on Open, you can choose the protocols you have already made or the ones you have brought from scienceBeam. For example, there are some predefined protocols which you can provide through the support team. I open one named Baseline. As you see, there are several timings in this protocol. T1 is the amount of protocol delay, which is set to 10,000 microseconds now. T2 is pulse duration or width, which is the time period when the stimulation is supposed to be applied. T3 or pulse cycle, which defines the intervals between stimulations. N1 or train is the number of stimulations. Now I'll make it more, as you see. 4 stimulations with the interval of 1000 microseconds in between. I return it to 1 again. This top line is all stimulation parameters. The bottom line is recording parameters. There are 3 options. Trial number sets the number of repeating stimulation parameters. If it is 10, it will save this protocol in 10 separate files, of which you can take average later on. Trial period is the time period between trials, which is 10 seconds now. And recording time is the time period we want to save from the whole test. We can make this smaller because in LTP recordings, we only want to have stimulation and the EPSP response after the stimulation. You don't practically need a 10-second file. 1 second is enough to save. We certainly mark stimulator 1 here as well as pattern 1. We go to File menu to save the mate protocol with any name. I name it Baseline 2. You can use an empty default by new protocol to make your own protocol completely from the beginning. 10,000, 200, 1,000, 1, mark sync, repeat the protocol 100 times with the interval 2 seconds, of which 500 milliseconds be saved. I save as ptest, protocol test. In this section, you choose the protocol you have made. I choose ptest here. Click on Scope. No stimulation is being received now. I'll stop again. We make stimulator normal. As soon as you start, it starts exerting the stimulation. Every 2 seconds, you can see the stimulation artifact. To make the stimulation fully visible, you make trigger on. Now, after 10 milliseconds, you will have stimulation, and if the electrode has been put at the specific point, you will observe the after stimulation EPSP completely. In the next film, we will teach you how to analyze real EPSP data.